Firstly, I will talk about the ultrasound machine observed at the clinic. This machine is a non-invasive diagnostic imaging device that uses high-frequency sound waves to produce real-time images. It is commonly used for obstetric, abdominal, and soft tissue examination. The main components include the monitor, control panel, transducer, and main console, which work together to produce accurate and clear diagnostic images. The ultrasound machine is procured through an authorized medical equipment vendor after obtaining quotation and management approval. The vendor is responsible for delivery, installation, and initial setup. During installation, checks are performed on room suitability, power supply, and system configuration to ensure the machine meets manufacturer requirements before use. Before clinical operation, the ultrasound machine undergoes testing and commissioning, which include functional testing, electrical safety testing, and system verification. Calibration is also performed to ensure accurate image quality. For maintenance, preventive maintenance such as cleaning and calibration is scheduled regularly, while corrective maintenance is carried out by the vendor if faults occur. Basic daily checks are performed by clinic staff. The ultrasound machine supports patient safety by avoiding radiation exposure and ensuring accurate diagnosis through regular calibration. Risk management includes managing equipment downtime and referring patients with unnecessary. Important documentation such as user manuals, service logs, test reports, and acceptance checklists are maintained to ensure safe and traceable equipment usage. Based on observation, the ultrasound machine is in good condition and suitable for clinic use. However, improvements such as scheduled preventive maintenance, digital maintenance records, and staff refresher training can reduce downtime and improve patient safety. This improvement also add value by lowering long-term maintenance costs and improving service efficiency.
For electric heat sterilizer, the model is Canbo XDR50D7X. It sterilizes non-critical metal instruments using high heat and ozone without water or chemicals. Key features include 200 to 250 dry heat, stainless steel chamber, timer, and temperature controls, and an indicator lamp. The price is RM700 to 750 with an annual service of 100 to 250, suitable for small clinics. For procurement, the clinic procures the sterilizer through direct quotation. The vendor provides a quote, the clinic approves, and the unit is delivered and installed. It is placed on a flat ventilated counter with a 13A outlet, and the chamber must be clean. Pre-checks include inspecting the chamber, door latch, heating function, timer, and temperature knobs, and indicator lights. The unit warms up in 5 to 7 minutes. Next, functional tests are performed by setting the temperature and timer to ensure proper operation. Safety checks confirm no electrical leakage, no unusual smells, and that the outer surface stays below 60 degrees Celsius. The sterilizer is accepted once it passes all functional and safety tests and acceptance criteria, ensuring it is ready for safe use in the clinic. The clinic practices preventive maintenance by wiping the chamber after each use, deep cleaning weekly, checking the heating element and door seal, and recording usage in a logbook. For issues like slow or no heating, the vendor performs corrective maintenance. Risks such as overheating, incomplete sterilization, or element failure are managed by monitoring each cycle, switching off the device after use, following a monthly checklist, and keeping the vendor's emergency contact handy. Regarding documentation, the clinic maintains a sterilization cycle logbook, maintenance and repair records, vendor service reports, and a basic commissioning checklist to track performance and safety. For spare parts availability, common spare parts include the heating element, thermostat, door seal, and temperature knob. These parts are supplied by the authorized vendor with a lead time of about 3 to 7 days, which helps minimize equipment downtime. Lastly, the turnout panel shape component focuses on improving maintenance efficiency. By implementing scheduled preventive maintenance and simple temperature calibration tools, the clinic can reduce downtime, improve sterilization accuracy, lower long-term repair costs, and enhance patient safety. This creates value through cost savings and higher service quality. In conclusion, the electric heat sterilizer is a cost-effective, reliable, and essential device that supports infection control and safe clinical operations.
Now, I will explain about automatic hematology analyzer. The model is Zebio Z3 3-part differential. The function of this equipment is to automatically analyze blood samples and produce complete blood count result. The cost of equipment around 35,000 ringgit to 45,000 ringgit, and the service cost is 2,500 to 4,100 ringgit per year. Now we go to procurement process and procedure. The equipment was purchased by the clinic management through an authorized medical device vendor. This process involved requesting quotation from multiple vendors, comparing them based on price and quality, and selecting the most suitable option. There are 3 steps of installation. First, site preparation. Ensure table is stable, can support the analyzer weight, and check for proper ventilation, lighting, and UPS. Second, unpacking and assembly. Follow the instruction provided by manufacturer. Third, power and network connection. Connect the analyzer to the power supply. Pre-commissioning checks. First, visual and physical inspection. Second, electrical and software checks. Third, fluidics and mechanical checks. For reagent and calibration checks. And lastly, safety and compliance checks. Testing and commissioning procedure. Functional tests to ensure that all components of the analyzer, like the sample probes and detection system, are working correctly. Second, calibration to ensure the analyzer produces accurate measurement. Safety checks to make sure the analyzer is safe for both operators and samples. And lastly, acceptance tests. Acceptance tests confirm that the analyzer meets performance standards. Current maintenance practice. First, preventive maintenance. Schedule checks to prevent breakdowns. Second, corrective maintenance. Fix after equipment failure. Predictive maintenance. Monitoring to predict issues before they occur. And maintenance approach, they have in-house and outsource. In-house, routine checks by lab staff. And outsource, complex repairs or calibration by manufacturer or vendor. Risk management. For patient safety, the risk faulty test results may affect diagnosis or treatment. So the strategies is run quality control samples regularly to validate results. For equipment downtime, the risk analyzer may stop working due to mechanical failure, software issue, or lack of maintenance. So the management strategies is schedule preventive and predictive maintenance. For backup plans, the risk mitigation, minimizing impact if equipment fails. The strategies maintain a backup analyzer or access to another lab. Documentation, service logs, record servicing, repair and maintenance activities, test reports, acceptance checklist, and CMS entries, track maintenance history, faults, and service schedule. Spare parts availability, vendor sourcing, lead time, delivery time monitored to reduce downtime, inventory management, critical and frequently used parts stock and track. Lastly, technopreneurship components. Implementing preventive maintenance for the hematology analyzer reduce unexpected equipment breakdowns and minimize test interruption. Regular calibration and quality control ensure accurate blood test result, leading to lower repair and repeat testing costs, while improving patient safety and laboratory efficiency.
This is electrocardiograph ECG machine that have in this clinic. This brand is Contact ECG 300G electrocardiograph, digital 3-channel 12-lead ECG. Its function to record electrical activity of the heart. Display characteristic waves such as P wave, QRS complex, and T wave. It helps to detect arrhythmia, heart attack, enlarged heart chamber, and electrolyte abnormalities. It print or record ECG report for clinical use. Another component that comes in ECG is first main unit ECG console. Second, display screen, which is LCD or LED. And then control panel, ECG lead wires, electron or link clip. And last one is battery and power supply. For this equipment cost, for purchase price, it is under the range 1,800 until 2,100. It depending on retailer, region, and included accessories. For service cost after 1 year warranty is depending on the service center. And the procurement process, vendor provide quotations, product payment, and technical data sheet. Quotation process is direct purchase from the approved supplier, and the selection based on price, technical safety compliance, and after-sales support. Next, installation and pre-commissioning. First, for installation, unpacking and inspection. Verify all accessories are present as listed in the user manual, and look for any visible damage that can happen during the shipping. Second is power connection. Connect the device to the appropriate AC power supply using the provided power cord. Third is connecting lead and electron, which is connect the 12 lead patient cable to the main unit securely and attach the limb and chest electrode to the corresponding lead wires. And for the pre-commissioning, first read the manual. Follow the procedure that described in the official user manual. Second, safety classification check. Device safety specification, which is class 1, type CF, and defibrillation proof applied. Confirm it is safe for direct heart contact and used during defibrillation. Third is physical damage inspection. We need to visually inspect the machine for any frying, crack, or loose connectors. Last one is lead wire detection test. The machine displays the lead off if an electrode is not properly attached or making poor contact. Now let's move to testing and commissioning procedure. First, functional test, which is power on-off test, display and button functionality, print test, and lead detection test. For criteria acceptance is screen clear, no flickering, and button respond correctly. For the calibration, we use ECG signal stimulator to verify waveform accuracy and check heart rate accuracy using standard calibration values. And for the criteria acceptance is correct amplitude display and printed. The last one is safety test, which is leakage current test, earth continuity test, and insulation resistance check, which is we using safety analyzer. For the criteria acceptance is without within IEC medical safety limits. Now let's move to current maintenance practice. First, preventive maintenance, which is scheduled every 6 to 12 months. That clean electrode, check cable insulation, battery health check, and function test and calibration verification. Second is for corrective maintenance, we replace damaged leaks wire, repair faulty display or button, and service printer mechanism. And the last one is for predictive maintenance, we monitor frequent error or weak signals to predict failure. And clinic may perform preventive maintenance in-house with biomechanical engineers. Okay, now risk management. First, for equipment downtime, we need to keep spare lead wires and electrode and have backup ECG if the clinic value is high. Second is for patient safety, we need to ensure proper installation of cable and follow infection control. And the last one for backup end, we use manual vital monitoring while waiting for repair and redirect patient to another unit if required. For documentation requirement, first the preventive maintenance log that record routine servicing and inspection of the ECG machine to prevent breakdown and ensure proper functioning. That's the corrective maintenance report for document file repair and part replacement when the ECG machine fail or malfunction. The last one is safety report that record electrical safety test and check to confirm the ECG machine is safe for patient use. Last one, the entrepreneurship component and improved maintenance and testing strategy for ECG machine can transform routine equipment management into a cost-saving, safety enhancing, and efficiency-driven solution that creating measurable value for healthcare facilities.